Okay, welcome back. What we want to do is continue with types of electrical system, part B. Okay. Outcome 3A, identify the different types of electrical installations and systems. Okay. Identify the different types of electrical installation and systems. Revision of previous sessions. Lighting types depend on the setting and client's preferences. Lighting controls also vary depending on the setting and client's choice. Heating has three forms of transfer: radiation, conduction, and convection, and we looked at that previously. Okay. Outcome from this session: at the end of this session, you should be able to state what power supplies are used for domestic and commercial installations, know what types of controllers to use for various types of heating installations. Okay. Domestic power supplies. There are three common ways in which the supply enters either a domestic or commercial premises: TNS systems, TNCS systems, or TT systems. Now be aware for any changes in regard to these type of systems in the modern day 18th edition of the IEE regulations or the 19th edition of the IEE regulations. So make sure you are familiar with the standards and the supplies arrangements. It is in your interest and your responsibility to do that. Okay, no one else's. The terms relate to the earthing arrangements. The letter refers to how the earthing arrangements exist at both the supply end as well as the consumer end. And here we have supply, cable, cutoff unit, meter, main switch, and consumer unit. Requirement of an incoming supply. Okay. Now supply types. First letter T, for instance, would refer to earth arrangement at the source, usually the supply transformer. Second letter, earthing arrangement at the consumer installation. Other letters, how protective conductors and neutral conductors are dealt with at the consumer's installation. Now remember that the protective conductor and neutral conductor in some cases can be bonded together at the consumer unit. So be aware whether or not they're bonded or whether or not they are individually terminated at that point. That will determine the type of system that you have. Okay. And here you have IT. So I'm telling you what those systems are. And here you can look at this from a TNCS criteria. Okay, a separate neutral and productive conductor throughout, common on all service cables. All new services are PME and PNB. Okay, meaning that you now have the neutral and earth conductor connected at one point. Okay, now make sure you understand the lettering. Make sure you read and look at the IEE regulations to ensure that you are dealing with current standards. Do not assume that this is the only information. Make sure check, and double check. It is your responsibility to employ and implement all safety measures. Okay. Types of supply. Here we have a star transformer, okay, local substation. Your grounding is down to ground, okay, iron core is center, goes to earth, and you then have your 1, 2, 3 phases plus neutral point, okay, and this is how they are fed. Consumer units, or I should say domestic dwelling, and industrial area dwelling, okay. Now here is showing you here a TNS system. The TNS system has a separate earth arrangement throughout. The dotted line shows where the split occurs, okay? Here's your earth, okay? And it will be bonded to the consumer unit will then be earth to this, okay? And that earth would be consistently separate to anything else. If the consumer puts anything on the supply or authorities equipment without their permission, then they can be prosecuted. Okay, you cannot put anything more on the consumer on this supply than the consumer unit. Everything has to come from the consumer unit. Okay, that is in regards to a domestic supply. Now here we have a TNCS system. The cable supplying the consumer is a CNE, combined neutral and earth cable. The only difference between this and the TNS system is the earthing arrangement at the intake point. Here we have the neutral connected to the earth, okay? Solid link, okay? And the same would apply at the consumer unit as well, okay? The consumer unit would be earth as it is, and you have your neutral supply coming in, okay? But at the earth incoming of the main supply from the supplier, it would be solid linked to the neutral. Okay, earthing conductor provided by the consumer but terminated onto the neutral conductor in the CNE cable by the supply authority. Okay, they will have that coming out to you. TT system, the consumer provides the earth electrode and an RCD. Now obviously you have to, when you're putting in the earth electrode, you have to make sure that you have a good earth, because you may need to move the earth electrode to different masses of earth to get a good earth. Okay, that is very important. It is struck into the ground. Okay, this normally used on farms or somewhere out in the country. Now the off-peak method has approximately 15 different tariffs, but these tariffs may have since changed. In 2023, the price of energy skyrocketed. to an all-time high. Okay, so be aware that some of these may no longer exist as such, but it's always good to know what we had before and what we may have lost. Okay, consumer unit, meter unrestricted, meter restricted. Okay, time switch, which would bring on your circuits for your off-peak heating or so forth. Now with white meter or economy 7, now economy 7 doesn't exist anymore to the best of my knowledge. Something else may have replaced it, but I doubt it. Only 1 meter is used. Okay, your serial connector block is simply feeding your consumer units basically for your heater or whether for your domestic supply support. And commercial power. Now what this shows you here is how systems are connected. Means of control that you have, this would be a bus bar box. Okay, bus bar chamber. Basically from your bus bar chamber you have switches going to each support. Each switch will control a distribution, three-phase distribution board. Okay, three-phase, let me rephrase that, three-phase and neutral distribution board, of course with earthing terminal. Okay, this arrangement is common in small commercial arrangements. Without splitting maintenance would be almost impossible. A single supply feeds a main switch fuse, which in turn feeds a bus bar chamber. Okay, and this would be your mains coming in from the outside, from the national grid. Okay, the large connector block and individual switch fuses for each of the split down loads are tapped off the bus bar. And here we have this again, and also large switch gearing. Okay, again, in most large industrial installation, integrated units are chosen. The setting out will depend on the requirements of the installation. The equipment must be able to withstand the prospective short circuit currents. Utmost care must be taken when choosing and installing this type of equipment. Okay, this is your main large switchgear for supplying something like Land Rovers, or supplying Kia car company or something of the sort, or a very large factory production, etc. Okay, so that's a system which would be utilized for that purpose. Now here we have control mechanisms, free heat switch. Cooker elements sometimes have a free setting switch. Okay, you can see here phase 1. Low heat elements are connected in series. This diagram shows the cooker with both elements connected in series. If the resistance is increased, the current must fall. In this diagram, only one element is connected in the circuit. The current has doubled and so has the power. Therefore, we can increase the power because we're only using one. And you can see the phase conductor making contacts with the switches here. Current is going here, yes, but nothing's happening because it's not connected to anything. And it goes around here, follow that point, and to your neutral. Okay. And high heating elements are connected in parallel. Okay. So you have each element here. In this diagram, both elements are connected in parallel. In parallel, the resistance halves, and so the power doubles. This is the highest heat position. Okay. The thermostats and thermostats. Now what this is showing you here is how it works. Okay, I don't want to go into close call. I don't want to lose the picture of it. Okay. Thermostat. A thermostat is a bimetallic strip wound with a coil. Okay, so you can see here that it pivots. Okay, on something. You have a control cam. Okay, you have operating stud, and you have a fixed contact point, moving contact. As this heats up and comes to a point, it causes this contact to press down and separate and open up that contact. Okay, which prevents the heat from heating up any further. So you are able to exert control by simply varying the temperature or the current at which this bimetallic strip operates. The coil around the bimetallic strip acts in tandem with the current passing through the cooker element. Current flows through the heating element and also through the coil wrapped around the bimetallic strip. The bimetallic strip warms up and closes the contact. Current through the heating element is then continually interrupted and reconnected as the bimetallic strip moves and closes, opens and closes, opens and closes. Okay. Infrared. The infrared found in immersion heaters operates in the same principle, except the rod does not expand, everything around it does. Brass tube, okay, inverse steel rod, fixed contacts, moving contacts, okay. As the infrared operates, it pushes the contacts or it pulls it in accordingly, okay. This type of arrangement is slightly different to the normal bimetallic strip, but the principle of expanding materials at temperature is the same. Oven thermostat, okay. Bulb containing a volatile liquid. This is called a capillary tube. Fixed contact bellows, okay. Moving contact. So this contact moves in and open accordingly to control knob, to what the setting of the control knob is at. Here a tube is filled with liquid that responds rapidly to heat change. When the liquid expands, the bellows expands and break the contact. Okay. Then as it cools, it goes back and it makes the contact. Okay. A thermal cutout, and this would apply to, well, it was going to apply to anything actually, but I was going to say it would normally apply to motors. That's what you can apply to anything. We have a three-phase and neutral system here. The thermal cutout is a thermally dependent resistor. As the resistance increases, the current decreases until there is insufficient current flowing. The circuit will then open. This diagram shows how a thermal cutout might protect the winding of a motor, and we do use thermal cutout on motors because they provide a very effective means of protecting the motor from overheating. Okay. All we're doing here is showing you that your control, start, stop. Now stop is in series, okay? Once you make a contact, it pulls in the contactors, okay? Retains the circuit in place. This lamp here tells you that the motor is running, okay, etc. And if the motor becomes over hot, that picks up the sensor and it breaks the contacts between it. Okay. Well, that's it. Thank you. I hope you found it useful, and check with you again soon. Take care. Bye bye.